Okay, so solving graphically. Now, all the steps that are above, I'm not going to talk through them right now because we're going to go through it together when we solve a problem. But they're there if you want to put them on your study sheet. And that's why I put them up there. So those are all the steps we're going to take today. So graphing this, we start off the same way we started yesterday. And what did we do yesterday? Put it into y equals mx plus b. So step A, put into y equals mx plus b form. Okay, well, just wait, Matthew, we'll get there. Okay, so equation 1, x plus y equals 2. We have to make it y equals, y by itself. So first step, everyone put your calculators down. Write down the notes. We'll get to the calculator in a moment. First step for solving for y. Move the x. So minus x to both sides. And we have y equals, let's put the x first. How would you write that? Negative x, and what's the sign on the 2? Plus to positive 2. Okay, that's our first equation. Number 2. Second equation, 2x minus y equals 7. First step. Move x. So if it's a positive 2x, we are going to minus it. Minus 2x to both sides. Those are gone. Now be very careful. This is where students make a mistake. What am I going to write on the left side of this equation here? Negative y. Right? You need to keep that negative is with the y. And now what? Negative 2x plus 7. Okay, are we done? No, we want positive y, not a negative y. To divide everything by negative 1. We have y equals, if I have two negatives being divided, what does it turn into? Positive 2x, and then a positive 7 divided by negative 1, minus 7. Now, if I wanted to use my graphing calculator to get points to plot, okay? How did we do that? Well, first we had to do what in our calculator? Plug equations into the y equal thing, the y equal button. Equations into, and we're going to put a little box around y equals to show it's a calculator button. So grab your graphing calculators. Can you please go to y equals? Clear. Second quit. Okay. Sometimes calculator needs a good reset. There we go. Okay, y equals, let's plug them in. So first equation was negative x. It has to be the negative in front of the x, not a minus sign, or else it won't work. Right here. What? Plus 2. And then we have 2x. Now, when it's between two numbers, you have to use a minus 7, not a negative 7. Oops, I just did negative. Minus 7. Okay, so use a negative button when there's a negative sign, there's nothing in front of it. Minus is when it's between two numbers. Okay, now if we want to get points, what do we push? Second graph. Now, you have y1 and y2. So second graph is how we get to our table. So table, we do that by second graph. And that's another way we can get points to plot. Second graph. So for example, the first graph, let's find 2 points to plot. And then we'll draw a line. I like to use the 0. So 0 and 2 for y1, 0, 2. So x is 0, y is 2. That's another point. 1 and 1, let's use the other 0. X equals 2, y is 0. How many points do you need to draw a line? Just 2. 3 if you want to make it look nice. But now that we have some points, can we draw our line? Yeah. Alrighty. Okay, first line drawn. Now, second line, you have to look at x and y2 for some points. So when x is 0 on the second graph, y is -7. So 0 and -7 right there. And another point, maybe we can get the other 0. 0, -7. Oh, we can't see it, so let's just choose another one. Maybe 5 and 3. X is 5, y is 3. We just need another point. 3 and -1. Guess what that's going to be? Our solution, right? Because they both share the same y at 3x equals 3. Okay, let's plot 5 and 3. X is 5, y is 3. And then connect those points. Okay, I need to edit my graph, obviously. There we go. So we can see where our point is, but how do we use our calculator? Well, I'm going to teach you how to do that. So on your calculator, to find your intersection point, we have to push the graph button. How so? Okay, go to your y equals. Do you have a -7 instead of a -7? Because I think you have a negative. Is that the issue? You -7. Yeah, -7. Better? Yeah. Okay, so push graph. There's our graph. So this is how we're going to actually find the intersect. Second, so everyone walk through this with me the first. We're going to walk through it together. Push the second button, then trace. Then 5 for intersect. Now at this point, it's basically say where is the intersection on the first curve. That is only useful if there's more than one intersection. Because we're doing lines and there's only ever one intersection, we can just push enter 3 times and it'll give it to us. So enter for the first curve, enter for the second curve, and a guess, enter, and there it is, 3 and -1. Okay, so this is our steps. We push second, trace, 5 for intersection, and then enter 3 times. Enter times 3. And because there's only ever one intersection in linear equations, we don't even have to scroll over to where it is. We just push enter 3 times and it'll give us the intersection. Okay? So can you try the next one? Or do we do it together? Do you want to do it together? You can do it? Yes, you can. Okay, try the next question. Oh, did we write our solution here? Uh-oh. What's our solution? 3 and -1 is our solution. Don't forget to actually write the answer. That'd be silly. Just find the coordinate. Yeah, that's what we're always trying to do this unit. I'm going to show you something else that's really cool on your calculator after.
I'm excited.
So first, solve for the next one on your own. No. Try the next one. Put in y equals mx plus b form. Get both of them as y equals. Then you can plot it in your calculator. Got it? Done? That fast? You decimals. You might get it. That's okay. Now, there's a way that we have to turn it into a fraction. I'm going to teach you that. Kind of, yeah. All right, so your first equation, let me catch up to you. 2x plus y equals 3. So our first step was take away the 2x. We get y equals negative 2x plus 3. Our second equation, 4x plus 3y equals 5. Take away the x. We want y by itself, and that's who's hanging out with y right now. 3y equals negative 4x plus 5. And then last, divide everyone by 3. Okay, so we need to plug in these equations into our calculator and get some, 5 over 3. So that's what you should have for your equations. Did you have that? Awesome. Okay, so in your calculator, the first equation was a negative 2x plus 3. The second equation was negative 4 divided by 3x plus, you don't need brackets. You don't need brackets. Because x is not on the denominator, it's on the numerator. So by putting it just beside, it knows 4 divided by 3 times x. Okay? So now that we have that in there, if we want to go to our table to plot some points. So second graph, just because we're making a graph ourselves. So the first graph, I'm just going to use 0, 3, 0, 3, and let's plot, I don't know, negative 2 and 7, negative 2, positive 7. So I'm plotting some points on the first graph. So we're looking at the x and y one. Okay? Once we have at least 2 points, we can grab our ruler and draw a line. No, it doesn't matter. No. Now my other graph. Okay, some nice points. Negative 1 and 3 is a nice point. X equals negative 1, y is 3. Right there. What else? So we scroll down. 2 and negative 1. That looks like an intersection point. How do I get the second y? Because I have 2 equations in, y1, y2. So second graph, we're just looking at the x and y2. So you can scroll down again, like 5 and negative 5 is a point. 5, negative 5. And so now that we have at least a few points, we can draw our line. Now in your assignment, you don't always have to draw the graph. Right? You can just use your graphing calculator to get your solution. So using our graphing calculator, once we're in graph, we have to see our graph. Well, you don't have to actually, but it's nice to see it. That looks like ours, what we drew. Okay, so this is where, now what do we push next? Second, trace. We're going to go to 5 for intersection point, and then we push enter 3 times, and our answer is 2 and negative 1. So our point is 2 and negative 1. Now let me show you something really cool. When you find an intersection point, your calculator automatically stores those numbers as the new x and the new y. So if I quit out of my graph, checking my work has never become easier because it's automatically stored our x and our y for us. So I can type in my original equation, 2x plus alpha 1 is y, and that should equal to 3. And I can go straight to typing in 4x plus 3, alpha 1 is your y, and it gives you 5. Whenever you find an intersection, it automatically stores that as a new x and a new y, which is awesome. Now this is also great because if your intersection is a decimal, you can type in x, math, enter, enter. Oops. X, math, enter, enter. And it'll change it to a fraction if need be, if it was a decimal. So it automatically stores your x and y for you. Pretty cool. So checking has never become easier. All right, one more. Let's do this one without graphing, without using, not graphing on paper, but just using our calculator. I know, that's why. Your graph did not show up very nicely. So can you solve this problem? Okay, solve using your graphing calculator. You don't have to, your graph didn't show up nicely, so you don't have to graph it on paper. You just have to use your calculator. Okay? So I'll solve the equations for y equals so you can check your answer to see if you solved them correctly. And then you might have to use another feature on your calculator for this question. Because our y-intercepts are very big. All right, so first equation, you should have subtracted the 5x. So 3y equals negative 5x plus 65, and then divide by 3. You have to keep it as a fraction because 3 does not go into 65. Please leave, don't forget to write your x. So leave that as a fraction. The second equation was really easy to solve because once you just move the 2x by subtracting it, y is by itself. Okay? All right, so with this graph, when you graphed it, y equals negative 5 over 3x plus 65 over 3. And then your other equation, you could push clear to delete an old one. Negative 2x plus 25. Now, when you graph this, can we see our intersection point? Oh, barely. Sometimes you can't. Okay? And if it's not in your window range on your calculator won't find it. So we change the windows. Now, the easiest way to change the windows is zooming out. If you push the zoom button and we want 3, zoom 3 is how we zoom out. But we have to push enter as well. Zoom 3, enter. And you can keep pushing enter if you need to. So when you're dealing with problems where your window range is way out there, just zoom out. Zoom 3, enter. And then you can keep pushing enter if you want to keep zooming out. Now that gives us a little bit better view of our graph. Right? Now, how do we find the intersection on our calculator? You can't see yours? Second, trace. 5. Enter, enter, enter. And our solution is 10 and 5. Okay, so zoom 3, enter. Zoom 3, enter. Yeah, you have to push enter. How do we reset the windows? We push zoom 6. So to reset your windows, push zoom and you'll see standard is number 6. So to zoom standard is to go back to the original setting. Zoom 6. And there's back to original. All right? All right, one word problem and then we're done for today. You forgot an X. Yeah, you did. Good. 1 second. All right, so I'd like you to try and write the 2 equations. Write the 2 equations here. In word problems, our first step is to define our variables. So what are we looking for here? When it says, how much sodium is in a bowl of cereal and a piece of bacon? The nice thing about a question like that is it tells you what your 2 unknowns are. So let's choose 2 variables. What are our 2 variables? Let's use B and C. Or you can use X and Y because we're going to use our graphing calculators. So let's keep it B and C for now, and then we can change it to X and Y after. So B is, what does B stand for? Please do not just say bacon. What does it stand for? What about the bacon? The sodium per slice, the amount of sodium. Well, because they're both, it's in 1 slice of bacon. And then what is going to be the C? C will be the amount of sodium in a bowl of cereal. Yep. Yep. On a word problem, yeah, you have to define your variables. Don't worry, there won't be many word problems. This will be a couple. Just a couple. Okay, so next, we need to figure out our two equations. Now, usually each sentence is an equation. So the first, well, after the first part, the first real information comes from, Owen ate 2 bowls of cereal and 4 slices of bacon that contain 940 milligrams. Can we make an equation out of that? What's the equation? Isaiah? Let's see. 2 bowls of cereal and 4 slices of bacon contains a total of 940 milligrams. Take a guess. 2 slices of cereal, or sorry, 2 bowls of cereal. How could I represent sodium in 2 bowls of cereal? 2C plus 4 slices of bacon. 4B equals 940. Okay, next equation. He ate 1 bowl of cereal and 3 slices of bacon that contains 620 milligrams. Next equation. 1C plus 3B equals 620. Now, which variable do you want to isolate for, C or B? C is going to be a lot easier because we have one of them that's just 1. So let's isolate C. Basically, we're saying C is going to be our Y. Okay, so we're going to solve for C. So C, I'm going to make my Y, and bacon is my X. So let's isolate each equation for C. First step to get C by itself in the first equation. We want C by itself. Subtract 4B. 2C equals negative 4B plus 940, then we divide by 2. C equals negative 2B plus, what's 940 divided by 2? 40, what? It's 47. Okay, so there's our first equation. Second equation, isolate for C. Oh, where? Oh, yeah, I forgot a 0. I was thinking of shortcutting in my head. Forgot to add the 0. Okay, first step here. You could leave it as 940 over 2. It'll still give you the same answer. Yeah. Okay, so subtract 3b, and we get C equals negative 3b plus 620. So in our calculators, we can't put in C's and B's. We have to use X and Y's. So if you want, you could even rewrite each equation. This is Y equals negative 2X plus 470. You have to remember that you made your B your X and C your Y. Y equals negative 3X plus 620 again. So we're going to talk about windows and zooming out. Okay, so grab your graphing calculators. Let's try and find the solution. So I'll go to our Y equals. Clear the other two graphs, and let's type these ones in. Now remember, your windows are y-intercept as big as 470 and 620. Those are very big y-intercepts. So our windows, we need to change. Now the easiest way to change our windows, if we push graph, is to zoom out. But you're going to have to zoom out for a while before you see your graph. Did anyone try that method? They zoomed out. Did it 3 times? Let's try it. Zoom and 3. Push enter after you push 3.
That works.
Okay, you have to push enter. Then that's it. Still don't see it, so I push enter again. Still, I see a corner of it. Push enter a 3rd time, and there's my graph. Okay, so I had to zoom out 3 times. The reason why is our y-intercept is way at 620. That's pretty high. And 470. Okay, so what do we push? Second trace. 5, enter, enter, enter. 3 times. and there's our solution. Now, we have to remember, if we get x equals 150 and y equals 170, who was x? Okay, let me see. Bacon. Was bacon our x? Yes. So that's our solution.
And this one, it keeps going to the origin or where it's going.
Plus 940 over 2, negative 3x plus 620. No, it just looks like that. But it gives you the right solution. Okay, so x was, look where this was. X was the bacon. So therefore, there is 150 milligrams of sodium in bacon, in one slice of bacon. You need a sentence and a word problem. Slice of bacon and 170 milligrams of sodium in a bowl of cereal. So on a test, some questions I'll say solve by substitution or solve by graphing or solve, I'll tell you. But then there are other questions I'll say choose any method. Now if you choose graphical, you should write down your calculator steps. So even writing out second trace 5, enter, 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 to show your work somehow. Show me what you did to get that answer. So there's some work there. Now checking your answer again, your calculator automatically stores x and y. And so you could go ahead and type in, as long as you remember, y was cereal. Y was cereal. So 2y plus 4x should equal 940. You could use your calculator for that. 2, out of here, 2 alpha 1, alpha 1 plus 4x should be 940. Pardon me? All right, so that's it for today's lesson on using your graphing calculator. Remember that if you do, I just want to show one more thing. If you do get a decimal as your answer, so say my equation was 2x plus, I'm just going to give you a random equation, 2 random equations, and hope it gives me a decimal answer. Okay, so if I graph these two equations, remember, how do we put our windows back to normal? Zoom 6. Zoom 6. Okay, so if I look for an intersection point, second trace, 5, enter, 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 and I get an answer that's a decimal value like this. Now, if I ask for a fraction, remember your calculator automatically stores x and y in your calculator. So how I change that to a fraction is I push x, math, enter, enter, and it changes it to a fraction for me. And then alpha 1 for y, math, enter, enter. As soon as you find an intersection, it stores it. And so we can go back to our regular screen and change those to fractions to get our answer in fraction form. Awesome. Yeah, so why, don't write out the number and then turn it to a fraction. Instead, just do it right here. Okay? So that's it for today's lesson. What's your homework?